for climate change influence on the coast. I'm working in the area of refractory high entropy alloys. So
Hello and good evening to everyone. On behalf of the Office of Global Engagement, I'm excited to welcome you to the 14th webinar from the IRIS webinar series. My name is Richu George Philip, and I'm a part of the Office of Global Engagement. From the Ocean Technology Cluster, the research initiative presenting today is Large-Scale Ocean Research, led by Professor V. Sriram. This research initiative is proposed to carry out tests close to prototype conditions in the field of ocean research to gain valuable insight into key physical processes that remain a great challenge to contemporary scientific investigations. Professor Sriram is an associate professor at the Department of Ocean Engineering, IIT Madras. He is the recipient of Alexander von Humboldt Fellowship in 2011, Newton International Fellowship in 2009, DST Inspire Faculty Award and YF Fare at IIT Madras. He works in the area of computational hydrodynamics, extreme wave structure interactions, and experimental modeling. Joining us as the moderator today is Mr. Abbas Khair from Kyoto University, Japan. He is a leading researcher in the field of particle methods such as SPH and MPS. His group is very active in this field. He is the Associate Editor in Applied Ocean Research, IJO, and editorial member in Ocean Engineering, European Journal of Mechanics B Fluids. Also joining us on the panel are Professor Ira Didenkulova from University of Oslo, Professor K. Murali, Professor V. Sundar, Professor R. Sundara Vedivelu, Professor S. A. Sannasiraj, and Dr. R. Vijay Kumar, and Professor S. Abhilash from IIT Madras. A warm welcome to everybody in the panel. Thank you for joining us today. And a quick note to the participants, please use the Q&A to enter your questions and upvote questions that interest you so that the moderator can prioritize them later. Over to you, Professor Sriram.
Yeah, am I audible? Am I audible?
Yes, we can hear you.
Yeah, okay, thank you. Thank you, Richu. Thank you, Abbas, Professor Abbas, for moderating this session. So I will directly start the presentation, wasting the time. So just give me this share the screen. Yeah. So my screen is visible?
Yes.
Yes, please.
Yeah. Thank you. Thank you. So good evening and good afternoon or good morning from wherever you are in the world. And welcome to this IRIS webinar series on the Ocean Technology Cluster, wherein we are focused on the Center for Large-Scale Ocean Research, which we call as a CFLOR. So in this presentation, it's just a short presentation for 15 minutes, and then we'll try to take up the questions. So the overview is, I will try to introduce the team who are all going to work in this particular research cluster, as well as the challenges for many of the younger or new budding students. I will try to introduce the challenges in the ocean engineering in general, and then what are the research activity which we are going to carry out in this proposed center. And then I will try to introduce the collaborators who are part of this particular proposal. So the team consists of myself, which Richu has already explained, so I'm not going in detail about myself. And I would like to, the other persons or my colleagues from the same department of ocean engineering. Professor Murali is currently the head of the department. He works in the area of coastal morphodynamics, as well as he is leading the center in Center for National Technology Center for Ports, Waterways and Coast, which is of course funded by the Ministry of Shipping, wherein we are trying to look at the inland waterways and all those part in the national perspective. And Professor Sana Siraj is works in the area of wave breaking interaction, as well as in the statistical analysis, as well as in coastal engineering field. He has done a lot of works in the coastal engineering aspect in Indian context. And Dr. R. Vijay Kumar is the retired Navy person, and is a naval architect, and he works in the area of ship, reducing the drag reduction of the ship, as well as in the submarine design. And we have Dr. Abhilash Somyajulu. He is also a naval architect, and he works in controls system, as well as in AUVs, as well as is working on the data science as well as artificial intelligence. And the next person is Emeritus Professor R. Sundaravadivelu. He is one of the experts in the field of port and harbor structures, and he has done enormous amount of work in port design and as well as harbor structure design in India as well as in abroad. And finally, Professor V. Sundar is a well-known person in the field of coastal engineering, and he is one of the experts. He has done a lot of coastal engineering, practical coastal engineering solution to most of the Indian coast. And so this is our team, even though we all are from ocean engineering department, but of course, ocean engineering itself is an interdisciplinary program. And to introduce the ocean engineering in general, because the participants are mostly from different groups. So what I'm trying to do in this short presentation is I will try to give a brief bird's eye view of the entire center activities which we are going to plan, and what is the reason for it. So the great variety of waterways exist, from the swell waves to the breaking waves, which are generated by the winds, as well as the ship generated waves or the tsunamis, which occurs due to underwater volcanic eruption or due to the earthquakes or the coastal floodings and cyclone storm surges and all those things. You will have the effect of these extreme wave events. And so the main purpose or the motivation of this particular center or this particular cluster of research activity is basically, first we need to understand the challenges which in the ocean engineering. So one of the issues in the ocean engineering perspective is, of course, it is going to be a large sea area, which is of hundreds of kilometers, as well as it has highly nonlinear waves that coexist with the currents. And then we have a viscosity as well as turbulence effects with violent wave impact or aeration or hydroelasticity, and a lot of aspects which is going to be taking place whenever you are going to design a marine structure. So in overall sense, we have to look into from the large spatial domain as well as the large time scale, which is over, for example, in the coastal engineering problem, it is going to be over a period of decades. Or if you try to consider about the waves, we are talking about the 10 seconds or 12 seconds or 13 seconds wave period. Or in the case of tsunami, we are talking about 15 minutes or so. So we have to deal with this large spatial domain as well as a large time scale, as well as one need to look into the small spatial domain as well as a small time scale, such as a wave breaking interaction. It's going to be in milliseconds. And then what is the response of that wave breaking to the structure, whether the structure is going to be a fixed structure in the coastal region or in the floating structures in the deep ocean. So I will try to give just a quick challenges in the offshore engineering. Some of this figure is of course from a German course. It's a Fino1 platform. So wherein the height, the height of the FinoOne platform is basically 15 meters, and this is basically an observatory platform. So the challenges over here is suddenly at one particular event or one particular day, the sea will be mostly calm, and suddenly you will have a very huge wave of 15-meter height, and then it will hit, and then it will damage this entire FinoOne platform. So this is basically a catastrophe of that much activity of about 15-meter high. So it's basically a 3 or 4 story building. So we have to consider these events, occasional rare events, whenever you want to design the marine structure part. And if you try to go on for a floating structures, of course, we are dealing with extreme wave structure interaction, like green water shipping when the ship is sailing in the deep ocean. You will have a very rough event which is going to come across, or the ship capsizing due to the dynamic instability of it. Or recently, the recent thing is we are trying to deal with the renewable energies. So offshore wind turbines, we are going to deal with aerodynamics part, as well as the motion response of these structures, as well as the mooring line configuration, or for example, for a tidal turbine or a wave energy converters. So these are mostly a slender structure. So what would happen under an extreme event or a survivability condition? So these things poses a lot of challenges to the ocean engineering perspective, as well as coming to the coastal engineering. You will have during a storm events or a cyclonic activity, you will have an extreme events that is going to take place, and it is going to damage your coastal structures. Or during a tsunami, you will have a debris impact on the coast, or during an installation of a seawater intake. So this is from Lakshadweep Island. During the installation process, you will encounter an extreme event. Or you can go for protecting the coast, which is a long-term process. How to protect the coast by using groin field or ecosystem-based design. So these are some of the challenges which exist already in the ocean engineering, different verticals of offshore, naval, or coastal engineering. So normally, traditionally, what we will do is we will try to model, of course, using experiment, small-scale experimental modeling. Say, for example, the FinoOne platform, we can able to model the small-scale event and then try to recreate such conditions in the laboratory and try to understand the physics, what kind of impact it is going to take place. Or the capsizing of the ship, you can able to recreate that kind of particular event and try to understand the motion response characteristics of it, as well as the dynamic stability from the dynamic stability point of view. Or you try to understand the debris impact on a structure and then try to suitably design the structure for the you can able to analyze what happened, and then you can able to tell you how to do the design for it. And then extreme event, how to interact with it. But of course, yes, we can able to do this in a small scale modeling. But if you look at this particular picture, you can see that it is not a single fluid. It is going to be a mixture of air, as well as which is going to be compressed air, and then it is going to impact with the structure. So what would happen? So normally in ocean engineering, which we are dealing with the gravity waves, gravity is the dominating forces, then fluid method will be normally used, fluid model scale will be normally used. But what would happen under these scenarios is that the fluid model will not always work. There is going to be some kind of a scale effects. So scale effects will be occur because of we are not considering the other aspects like friction, compressibility, surface tension. So what is the solution? The only solution is that either you try to do in a large scale, or you try to go to the field and try to measure what's happening in there. But if you go to the field, the other challenge is you have uncontrollable boundary conditions. That means you don't know from where you can't be able to model in a controllable way in order to understand this entire process. So that is the reason for this particular scale effects. And in this particular center, what we are planning to do is we are trying to address this scale effects mostly by using a testing facility, which I will try to bring in. This is an overview of this entire center, wherein we have the testing facility, which is the part of this particular center, with the international research group, wherein we will try to give access to these large-scale facilities, which is quite few in numbers. And then we formulated a lot of research verticals, which I will try to describe briefly. And then we try to introduce some kind of workshops, international research projects, and industrial link, which is the core of this particular center. And so now coming back to the testing facility, so where this testing facility is going to be placed. So because this testing facility which you are talking about is in large scale, near to the prototype. So this testing facility is going to be located in our Discovery campus, which is 40 kilometers from the current IIT Madras campus. And it is going to be housed in this, the yellow one is basically the D, which says is basically a large scale testing facility, which we assume is going to be one of the world's largest once once we started constructing it. The length of the proposed length of the flume length is 500 meters with 8 meters deep and 5 meters wide. We have a deep pit of 10 meters with the current generation facility and towing carriage and significant weight. And of course, we are, as part of this center, we are also going to consider an intermediate testing facility. So the intermediate testing facility is going to be housed in our NTC PWC facility, wherein again it is going to be 100 meters long with a large stroke of 4 meters to generate a wave period from 3 to 6 seconds with a significant wave height of 75 centimeters. And the research verticals which we are trying to concentrate in this particular center is the scale effects. What kind of scale effects is going to take place whenever you try to model in the small scale, because the small scale results will lead to a higher force because it cannot able to model the compressibility effect. And the second research part is the survivability of the offshore wind or wave energy converters, because these wave energy converters are going to be very slender, as well as we are interested in integrating these wave energy converters into the existing coastal structures or offshore platform. So that is one of the aspect of this, center. And then we want to understand the statistical understanding as well as how defining the extreme events which is going to take place. And then Green Ship Initiative is one of the thing wherein IMO recommends the guidelines of the pollution free in the to reduce the greenhouse emission rate in the international maritime shipping. So we have to come up with the innovative technologies. One such technology to reduce the drag is air lubrication system. So again, we are talking about the two fluids. So normally the naval architects will try to model it by using the Froude law. But when you try to go over the bubbles, you can't use the Froude law. So you have to go to the large scale. So that is one of the aspects. And then we want to interested in the climate change as well as the nearshore coastal morphodynamics, as well as, of course, numerical modeling plays a major role nowadays. So we want to do a large scale, how to optimize the large scale by using a hybrid coupling between the different models. And then finally, the data science to understand the extreme ship responses as well as the wave characteristics in the ocean engineering as well as in offshore engineering. So in a nutshell, for the design of marine structures or to understand the complex wave soil structure interaction, we want to go to the large scale as well as small scale numerical model as well as the large scale experiments. The one which we have shown over here is from the Grosser-Vernal Canal, that is from GWK Hannover. So we want to do similar kind of effect in India. So these are our collaborators for this particular project. Professor Pierre Ferrand from EC in France, Professor Qingwei Ma from City University London, and Professor Torsten Schlurmann, Professor Holger Schüttram from Germany, and Abbas Kayer, who is moderating this particular session, as well as Professor Ian Nister, Ira Dinenklova, and Dominic Reeves, and Felice Arena, as well as gold medal from NTNU, and Professor Paul Kula from Texas A&M, and Professor Philip Liu, Professor Thorsten, as well as Shishang Yan from UK, as well as Professor Alex Babanian from University of Melbourne. So I take this opportunity to tell you that shortly in another 1 month time, we are going to through this activity with our collaborators, we are going to announce for a call for proposal between University of Melbourne. It will end up in a joint doctoral program wherein the students will stay some period in University of Melbourne, as well as in IIT Madras, as well as with ECN NANT, as well as at IIT Madras. So these are 3 different calls for joint PhD. You will be seeing in another couple of weeks or months time, because we are under the process. Because of COVID, we are unable to do this very quickly. So with this short and brief one, what is activity and what is the motivation of this particular center, I would like to close this session. Thank you. I leave to Professor Abbas. Thank you, Abbas.
Yes, thank you very much, Professor Sriram. So it's an honor for me to moderate today's session. So we have a few questions typed in the Q&A section, in fact. So I'm going to select some of these questions. So the first question is, how can we indulge with IITM in research programs?
So I think
you just mentioned about the joint PhD, but in addition to this, is there any other opportunities?
Yeah, so I request Professor Sana Siraj may answer this, so that I want to have some kind of discussion. Yes, Professor Sana Siraj.
Yeah, so yeah, good day to all. So to cover all these, be a part of the day. So there are many opportunities, and say the core objective is the development of the facility. So we invite everyone to do research work in our facility. Of course, we are aiming for the 1:1 scale. That's the main focus of the work. So apart from that, so of course, the joint PhD, the slide, you can see that there is a joint PhD, not only a joint PhD, there are postdoctoral opportunity if you already got the PhD, and also joint research initiative also can be initiated. And we are quite open, in fact, but only within the umbrella of a large testing facility, particularly this hydrodynamic testing facility. That's the main focus. And here, well, both waves and current, both are there. So there are unlimited opportunities can be opened up in this research forum. So I request Professor Sundar to add.
Yes, thank you very much.
Good afternoon to all, or good morning, or good evening, wherever you are. So I think whatever Professor Sana Siraj has mentioned holds. And in fact, we have a very good reputation for decades of work in this area with, of course, kind of smaller scale facilities. But many of them have been named, can be named as first of its kind in this part of the globe. For example, the multi-element wave maker, with which we had a strong interaction with Germany, and we had several sponsored projects sponsored by the German funding agencies, and we had a strong collaborative research that has led to a number of interesting publications. And I'm sure that we can set the ball rolling. It's only a continuation of whatever activities we have been doing, but now only thing is we are stretching our arm further, because our major partner was Germany. Now we are trying to stretch our hands globally, and I'm sure that there will be avenues for us to interact and carry out this further. So I wish you all the best.
Okay, yeah, thank you very much for your responses, because there are many interested participants today. They're asking how they can, for example, based on their expertise, how they can participate in this project. So there are a lot of interest, and there's a question here about the amphibious multi-medium robots. So is there any connection between the projects and the robotics control engineering?
I think Abhilash?
Hi, am I audible? Hello?
Yes, yes, please.
All right, okay. With respect to amphibious vehicles, I don't think we have currently anything on the books, but we definitely are always curious to expand further. And I think one of the main aspects of this center is that we'll be generating a lot of data out of these large-scale experiments. And it will be interesting to see how this data can be used to create generative models. So in essence, what we are trying to look at is, if we want to recreate an extreme event in the ocean back in our laboratory, how can we figure out what are the ways which will generate such extreme events? So in some sense of that, robotics doesn't directly play a role into it, but I think data science plays a much more vital role into such applications.
Okay, so thank you very much for your response. So there's a question about collaboration with companies, famous companies related to the offshore structures. If there are some collaborations for development of offshore structures joined with this project.
Yeah, I think Professor Murali can answer this.
Yeah, definitely there will be opportunity for a lot of collaborations. In fact, the facility of NTCPWC has been created due to a very strong collaboration with the industry, especially the port industry in India. Of course, there are also offshore and other industries who are involved, especially the people who are supplying port equipment in terms of handling and also in terms of monitoring the port activities. So therefore, we are quite open, and in fact, we welcome a collaboration from any partners who are likely to join hands with us or lend a hand, helping hand with us in order to promote the field. In fact, globally, if you look at the funding for hydrodynamics, we are still able to generate some funding because we still feel there are problems which are to be addressed. So therefore, we feel there is a lot of opportunity for collaboration, and we welcome that.
Okay, yeah, thank you very much. So there are some questions also related to the wave energy converters. So if there are some funding for development of wave energy converters, startup companies, and if exists, please give some explanation about this.
Yeah, Prof. Sundar, I think he can answer it because he is working on the wave energy partnership.
So we had a very good collaborative research project funded by the Norwegian Science Council that lasted for about 3 years, and we learned a lot through this. And in fact, India's first wave energy plant was established somewhere. It's a pilot plant that was established off Kerala as early as around early 90s. And we proved that the system works. It's basically an oscillating water column. And we have been continuing our work, but then standalone wave energy converter may not work, and hence we are now inclined to integrate this OWC into other forms, like for example, caisson breakwaters, which a large amount of work has been done other parts of the globe. But then now we are trying to include it or integrate it with rubble mount breakwaters and also the other forms of caisson type of breakwaters. Other forms is not the conventional caisson type of breakwaters, but other types of breakwaters. And we have been investigating, and we have a PhD program right now, which is in progress.
Yes, thank you very much, Professor Sundar. So we have a question from the panelists here. So how much room, lab time, will be given in the new large-scale flume for fundamental research? And are you interested in benchmarking alliance?
Yes, yeah. So the fundamental research, yes, the fundamental research is one of the things which we already specified the scale effects. That is basically fundamental research where we want to understand the room. If I try to look at it, yes, of course, we want to do both fundamental research as well as application oriented, because it's a large scale, so many people will try to do it. So that is, of course, yes, it's there. And what is the second question?
So benchmarking problems.
Exactly. Yes. Yeah. So the benchmarking and alliances with the large facility. Yes, correct. That is one part of this goal. I think Professor Torsten Slurman is also here. So we of course want to get it alliance with large wave flume in Hanover as well as other flume. Once this flume has become operational, of course we want to take a benchmarking with different facilities and try to come up with what is the accuracy level in each of these facilities. Yes. Yes. So the answer is yes for those things.
Okay, so if I may ask just one question to the panelists, because I could see the objectives very clearly, and also you mentioned about the about the larger scale and smaller scale modeling. So my main question is about so you definitely, again, about benchmark tests and so on, but also for reliability of the experiments. So we need to consider repeatability and also, and for the numerics also, because the problems that we are facing, as you mentioned, so they are multi-phase, multi-physics, multi-scale. So we do need like kind of systematic validation of the experiments and also numerics. And to understand the physical processes, probably this is going to be very important for, in fact, the reliability aspect. So if you can kindly comment on this matter, it will be great as well. You're on mute, Dr. Sriram.
Oh, sorry. For the reliability, I think I think Torsten Surman is the correct person. He is already there in the panelist, so he has already have experience. We are right now constructing, and they already have the GWK facility. So I request Torsten to discuss about this part. Yeah. Torsten, are you there?
I'm still there, but I didn't get the query here. Sorry.
Yeah. My question is simple. So how can we ensure the reliability of the physical modeling and numerical modeling?
That is a key question here, I would say, and this is also regarding my query I just sent in the chat line regarding the benchmarking effects. There are lots of data available worldwide, not just stemming from large-scale facilities, but also from numerical codings. And this is what I had in mind. And when I was first introduced with CFLOR and the large come up in due time in India, I was recommending also to keep a deeper look into these kind of how to bring these data together and to learn from different perspectives. And this is what I had in mind. And so I would be delighted if we could team up here, also maybe with colleagues from China, from Tianjin Water Research Institute, or from Deltares, who run the Delta Flume. And I think this is one league, this is one alliance, and India and IITM is just among the key players worldwide right now.
Yes, thank you very much, Professor Torsten, for your clear and detailed response. So there's one question here from the audience. And the question is related to some more details about the joint PhD program. If you would kindly just give us some more details, please.
Yeah, so this joint PhD program, IIT Madras is having MOUs with about 18 universities all over the world. And so this joint PhD program can be operational two ways. One is either from IIT Madras students can go after joining IIT Madras, if through, for example, through this IOE project, they can visit, and then it can end up in a degree, or the foreign, suppose if you are registered in the foreign universities, so the inbound students, that is, the students can come to IIT Madras and they will try to stay for a period of sometime for 1 year or 2 years. There is some guidelines. So once if you fulfill the guidelines, as well as once if you fulfill both the university norms, then you will get then they will be awarded the joint PhD program.
Okay, yeah, thank you very much.
Yeah. So I think I think the more details can be found in the Global Engagement Office website of IIT Madras regarding this.
Yeah, because also there are some questions if there will be funding for this kind of like joint PhD program.
Yes,
Okay.
correct. Yeah, there is a funding. Yes, there is a funding from IIT Madras also when you have enrolled into a PhD student. And once if you go to foreign university, you will of course get the foreign funding from the other side. So it's a matching funding. So that is why we have the MOUs. So it will not work with all other universities. So these are MOUs, fixed MOUs between different universities.
Okay, yeah, thank you very much. So there's one question, so it's very interesting because you mentioned about large scale experiments. And there's one question that these experiments will not cause some damages to the natural ecosystems. Because you mentioned large, but how large is that large?
So, so the large scale right now we are talking about is in the for coastal engineering aspect. If you look at the coastal engineering aspect, it is 1:1 exactly. So if we are talking about the water depth of 5 meters or so. So for coastal engineering perspective, it is 1:1. So if you are interested in a vegetation, wave vegetation interaction, you can able to study in a controlled environment over here in the laboratory. But if you look at, we do have as part of this, we do also have the towing carriage that is part of the proposal that will be having a reduced scale, or we are also having a deep pit of 10 meters. So that is for offshore structure. So there you will have some scale of it of 1:50 or 1:100, depends upon the problem which we are going to investigate.
Okay, yeah, that's great. Yeah, but the question was about the possible damages to the natural ecosystems, but we are not going to alter, we are not going to confront nature. So we are going to just...
Yeah, so we are normally, most of these structures are coastal protection structures, right? So we want to protect the ecosystem in better way.
Exactly, yes. And there are so many questions about biotechnology. I think there are many participants today from this field. So is there any link in between biotechnology and this project?
I don't think there is, to my knowledge, as of now, biotechnology, and I don't think so. But of course, fluid mechanics is the basic in two fields, as well as the multi-phase flow. If you look at it from fundamental physics, but the application-wise, I think these two are different.
Okay, great. There's one question. So I'm doing masters in mathematics. I'm eager to know if my area of expertise can be associated to ocean technology. Pure mathematics.
Mathematics. Yes, correct. Yes, yeah. That is what we are doing as a numerical modeling. Right? So it's a pure mathematical.
Yeah, so we would like to welcome Professor Philip Liu. So Professor Philip Liu, you have raised your hand, please.
Yes, I have a question because you mentioned several times that you have a large facility and look at the scale effects, all that. I'm just curious about two things. One is that are you going to allow people to use salt water in the tank or in the facility in general? Because from the fundamental science point of view, even the breaking bubble sizes and turbulence generations could be a little bit different between the fresh water and the salt water. Let alone if you are interested in the ecological problem in the coastal zone. Another question is that I think in the nearshore area, one of the issues that is gaining a little bit more attention is the interaction between wind, air, and the wave or breaking wave, or vice versa. Also, even the simple problem about how does breaking wave generate turbulence, air into turbulence, and those are real problems, and we largely just ignore them. Right now, I think there are some literature data is coming out. Now, in your facility, I haven't seen any mention about the wind generation or even have some kind of wind tunnel above the water tunnel. Do you have any thoughts on that? But because those problems are probably relatively newer problem directions, and is looking forward. So do you have any thoughts on that?
Yeah. Thank you, Professor Liu. Yes, actually, when I basically propose, when we are talking about this particular facility, so first one is we want to, I mean, I think Professor Toshan as well as Professor Holger basically suggested why you are going similar to GWK, why not you do have this wind generation part, I mean, the wind generation part. But the issue over here is it's going to be a huge investment cost in the beginning. So that was one of the reasons we didn't include the wind facility over here in this large scale facility. So that is a very good point. We are talking about the wind wave interaction and all those things, but yes, we have not included that. That is the reason, because of the purely from the cost perspective, because we don't want to include too many things into the proposal at this point of a moment. Maybe during the upgradation phase, yes, we may go for this wind tunnel facilities attached to it. And regarding the first question on salt water, yes, that is a good point. We have not, as of now, thought of it, because for the simple reason we have the wave makers and the instruments which may have some kind of issue. So that is one of the reasons we have not thought of salt water. Is still going to be fresh water only, and of course it is going to have some kind of a effect. Only after constructing it, we can able to see what could be the effect, whether we can able to change some of these equipment that can able to last for long during when we try to put in the salt water. Yes. So these are the two things which we will keep in mind during the upgradation phase of this facility.
Okay, thank you.
Thank you. Yeah.